Hi friends, in this video we are going to derive the derivation of RMS value of a sinusoidal voltage. Here RMS value means root mean square value. Okay. So in order to get the root mean square value for sinusoidal voltage, so first I am going to draw the waveform. So the sinusoidal voltage waveform we are having like this. Now here, so this is the maximum value or peak value of a positive half cycle, and we are having a value Vm represents the maximum value, and here we are having the negative peak value, that is minus Vm, and here this is 0, this one is pi, this is 2 pi, and this is 3 pi. Like this we are having the sinusoidal voltage waveform. Okay. Now whenever we are going for the RMS value derivation, so always we need to consider for complete cycle. Okay, whenever we are going for the average value, you need to consider only up to half cycle. Okay, so now we required the root mean square value, that is RMS value. So that is the reason why we need to consider the time period for one complete cycle. Okay, so one complete cycle. Now this is starting at 0 and ending at 2 pi. And here the expression V of t is equal to Vm sine theta. Okay. Now we know that the expression of RMS value or RMS voltage, that is VRMS, that is RMS voltage or RMS value, it will given by the square root of 1 divided by t integral 0 to t V of t square into dt. Okay, we can also use d theta also. Okay, so here you can use dt or d theta. If you are using d theta, then you can use sine theta. If suppose you are using dt, then you can use sine t. Okay, so like this we need to just change. Okay, now anyway we are using sine theta, so that is the reason why I am simply using 1 divided by t integral 0 to t V of t square into d theta. Okay, now assume this is equation number 1. Now we know that V of t is equal to Vm sine theta. Okay, now we know that the time period here t represent the time period, and here V of t is equal to Vm sine theta. Now substitute these two values in equation number 1 and simplify to get the value of RMS value of a sinusoidal voltage. Okay, now VRMS is equal to 1 divided by 2 pi integral 0 to 2 pi V t means Vm sine theta whole square into d theta. Okay, now again simplify, just simplify the expression. So here 1 divided by 2 pi integral 0 to 2 pi. So Vm sine theta square means we can write Vm square sine square theta into d theta. Okay, again simplify here. So square root of Vm square divided by 2 pi integral 0 to 2 pi, the remaining term, that is sine square theta into d theta. Okay, again simplify this expression to get the value of what? RMS value of a sinusoidal voltage. Now the next step is, so actually what is the last step? So VRMS is equal to under root Vm square divided by 2 pi integral 0 to 2 pi sine square theta d theta. Now again I am writing this expression here. So VRMS is equal to Vm square divided by 2 pi integral 0 to 2 pi sine square theta into d theta. Now instead of sine square theta, so we know that sine square theta is equal to 1 minus cos 2 theta divided by 2. Okay, so instead of the sine square theta, we can substitute this value for getting the RMS value. So VRMS is equal to so Vm square divided by 2 pi integral 0 to 2 pi. So instead of sine square theta, we are substituting 1 minus cos 2 theta divided by 2 into d theta. Now VRMS is equal to Vm square divided by 2 pi. Now here denominator we are having 2 pi and 2 pi, so that is the reason why I am writing this 2 here. Now remaining term is what? Integral 0 to 2 pi 1 minus cos 2 theta into d theta. Now VRMS is equal to Vm square divided by 4 pi square root of integral, so 0 to 2 pi 1 minus cos 2 theta into d theta. Now here integration of 1 minus cos 2 theta, so just apply integration for that particular term. So here Vm square divided by 4 pi. Now see, integration of 1, it will gives what? Theta, minus integration of cos 2 theta, it will gives sin 2 theta divided by 2 and having a limits from 0 to 2 pi. Okay, so we are having a limit from 0 to 2 pi. Now go for the next step. Now what is the next step? Next step, so VRMS is equal to square root of Vm square divided by 4 pi theta minus sin 2 theta divided by 2 having a limit from 0 to 2 pi. Now apply limits for this term. VRMS is equal to square root of Vm square divided by 4 pi. By applying limits, so theta first apply 2 pi, after that apply 0. So here by applying limits you will get, so 2 pi minus sin 2 theta means 2 pi divided by 2 minus of, now apply 0 limits, so 0 minus sin 2 0 divided by 2. Okay, now we know that sin 180 0, sin 0 0, it means sin 2 pi means what? Sin 2 of 2 pi, it will gives the total numerator term as 0, here also same, sin 0 0, so that is the reason why here also numerator is 0. So here VRMS is equal to Vm square divided by 4 pi into, so this is 2 pi as it is, and here the numerator completely 0 because sin 180 is 0 divided by 2 minus 0 minus sin 0 is also 0, so that's why 0 divided by 2. Now by simplifying this one, finally you will get only, so Vm square divided by 4 pi into, you will get only 2 pi. Now here pi gets cancelled, 2 ones are 2 twos are. Now final expression, that is VRMS is equal to square root of Vm square divided by 2. Now again VRMS is equal to, just I am writing like this for numerator and denominator, I am just like this, okay, writing like this. So root of Vm square divided by 2, I am writing root of Vm square divided by root 2. Now here 2 and root gets cancelled, the remaining term is Vm divided by root 2. Okay, now this one Vm divided by root 2 is a VRMS value, and we know that here VRMS is equal to Vm divided by root 2. I am also substituting the value of 1 by root 2 here. So 1 divided by root 2 into Vm, that is equal to 1 divided by root 2 means you will get 0.707 and Vm as it is. So here VRMS is equal to 0.707 into Vm. So this is the RMS value of a sinusoidal voltage.